So 4-9 quiz, the top 5 today was just sort of open-ended. Tell me what you read. So that's going to change into 15 specific points for next quiz. So any of these things are things that we could have absorbed by now. Some of them I've said already other days. Some of them it's the first time you've read about them, but it was around. So for the filling in this paper for the 4-9B study guide, when you write proofs, what is a thing that you should copy?
The given.
Copy the given.
Copy what you need to prove.
Copy what you need to prove. And before you even do all that, you probably copy or create, but usually copy a picture. So 30 to 32, there's 3 things that were in the reading. Always copy the picture or make a picture. Always write what's given, always write what you're trying to prove. Then they described something I described other days and we've done a couple times already. What makes it, how are we going to organize our work when it's like proofwriting time? Okay, what's in it? Yeah, how many groups of things? 2. So we're going to make 2 columns. One for, David already said it, one for statements and one for reasons. So 33, make 2 columns, one for statements, one for reasons. There's 2 other things the book said could be an aid to clearer thinking. For some of you, one comes naturally. For others, it definitely does not come naturally. The other one is just a little bit of advice that we could all use. Anybody have a thought on 2 other things the book said could help keep your thinking a little bit clearer, maybe? Call you out, you're naturally bad at one of them.
Organization.
Be neat. Yeah, draw neat. Write neatly would be a help to you. The other thing had to do with the picture. Anybody have a memory of the reading, something about pictures they talked about? We encountered this another day. There was a day that we were trying to draw lines on a circle, and I said this wouldn't be a good way to do it. Because we were trying to like count how many like zones we had in there.
Make it big.
Make a big picture. If you're going to draw a picture, draw it big enough that you're going to be able to write some stuff on it as you go. So when we make my way to my left, your right, and a little bit, you know, that picture's big enough. I can look at it, I can write on it, you can see it. I wouldn't like make that same picture that size on my board. That might work on a piece of paper, but on a piece of paper you wouldn't want to go like that. Like that's just not functional. So you want to draw relatively big pictures so that you can write things and look at the picture a little bit better. 36, they mentioned in this reading 3 things that if you see it and it looks like it, you can trust that it is it. Then for 39, they mentioned 3 other things that if you see it and looks like it, you have to play dumb and not take for granted that something is the way it looks, because we've had that conversation earlier in the year. You can't always trust your eyes. So anybody have a thought, 39's group of something that you're not supposed to trust your eyes, or have a thought on 36, something that you are allowed to trust your eyes?
36, is that the transitive?
No. Anybody else, something you can or can't trust your eyes? If you know, I'll take it. If you don't, I'll have to help life along. So here's a picture that gives me some information that I can trust my eyes. What is that a picture for? Betweenness. If it looks like something is between other points, you can trust that on your eyes. So if you're looking at a picture that has this, you could safely say that AB plus
BC equals AC.
You can safely say that. You can trust your eyes on something like that. So 36, betweenness, you can trust your eyes. Here's a picture of something you can't trust your eyes. You could trust your eyes for betweenness on this. But what other word does this look like it maybe is?
Midpoint.
Midpoint. You can't trust your eyes on midpoint. Just because it looks like it's in the middle, you can't say that. If I come out and say, as the teacher, as the author of a book, as a person who creates homework problems, one of us says, B is the midpoint. If we tell you that, then you can trust it. But you can't just look at that and go, I'm going to judge this for myself. No, sorry. If this is the midpoint, what could you say?
AB equals BC.
AB equals BC. Don't make that judgment unless they specifically use the word midpoint. Did that spark any memories about anything else? Okay, so I'll just tell you more stuff. Another thing you can trust is collinearity. C-O-L-L-I-N-E-A-R-I-T-Y. Whether things are collinear or not. So if I drew you this and it looks like A, B, and C are on the same line, it's because A, B, and C are on the same line. You can look at that and you can trust your eyes for that. That is legal. Another thing you could judge, I just put the point D, what's a word that I could use?
Interior.
In the interior. I just put the point E in the exterior. You can trust their drawings on that. If it looks like a point is in the interior, trust it. If it looks like it's in the exterior, you could trust that. If I made this little connection, what is that picture now leading me toward? Correct. It's not part of this paper, but that's just a valuable bit of reminder. So 36 things you can trust is between this. You could just write BET. Collinearity, you could just write COLL if you want. And then interior versus exterior, I wrote INT versus EXT. You can just look and judge that with your eyes. 39's collection, if you were looking at this picture, what maybe does it look like is a relationship here, but you're not allowed to just like trust it unless they use a word. Perpendicular. You cannot just look at a picture and be like, huh, looks perpendicular to me, and go off on that. That's not okay. Perpendicular means we're forming bunches of right angles. Okay? But we're not looking to do that. Unless they say this is perpendicular, don't do it. Those two segments look like they're probably, how about if I draw these, that's true. I did a bad picture. We couldn't trust that either, but we're not into parallel either. Those two angles look like they're probably congruent. You can't just think things are congruent and act like they are. Unless they tell you this is congruent, you can't just say, these are congruent, it looks like it. That's not legal. So 39, midpoint, you can't just make that up. Perpendicular. This is the symbol for perpendicular, if you want to not write out a word. Congruent, you could write the symbol, not the word if you prefer. You can't just make that stuff up. If they tell you it is, then it is. If it looks like it is, then it isn't. It's just not the way we play the game. 42. First statement. What's always going to go in the first statement blank? Okay, what's the name of that statement though? Yes. Hypothesis. The hypothesis is always the first statement that's going to go in every proof. What's the first reason, if it exists, generally?
Given.
Given. Given is generally the first reason. Last statement is always the conclusion. Once you have the conclusion as a statement, that's how you know it's time to give up. Well, not give up, it's time to celebrate. You have success. Question, those are all things that were in the reading. I don't know if any of that, well, some of that was definitely new to class. The trust your eyes, don't trust your eyes category, but some of that we talked about other days. Does anybody need anything on the first 29? Yeah. Number one is something like if D is in the interior of angle BAC, then the measure of angle BAC, again, is equal to the measure of angle BAD plus the measure of angle CAD.
Can we do 24 to 29?
Yeah, so we've got hypothesis versus conclusion is the main like categories there. The hypothesis is the if. The hypothesis is also what you're given. The conclusion is then the other opposites. It's the then, and it's what you're trying to prove. Is that okay, or want me to rewind?
Yeah.
Yeah. Yeah, it's over there. Anybody, any kind of anythings, 49B preview, can I help? 30 is copy the picture, and the given and the prove, P-R-O-V-E.
Do you care about the order of that?
I
on the
don't.
quiz?
No. But generally in life practice, it's picture, then given, then prove, usually in that order. But in a quiz answer, no, I don't care. Here's another thing. Whenever you say this, that is not the same as saying this. The prove with the B, that's like this one single item. The proof with an F is this entire massive structure of pictures, givens, proofs, columns, numbers, statements, reasons. So there's a difference there. So make sure when you're talking about what you're copying the prove, P-R-O-V-E. There's no occasion to really copy a proof, P-R-O-O-F. Something about preview, anybody? So homework situation, the newest homework, I won't get collected tomorrow. I would highly recommend you start it though for tomorrow. This is not a homework you want to do in one sitting. The homework's going to go on page 112. It's going to go from 1 to 16. It's all stuff based on proofs. It's mostly fill in the blank on proofs, which I've never been sure if it's easier to fill in the blank on a proof that someone else did, or if it's easier to just do it yourself. I sometimes feel like it might be easier to do it yourself than try to put yourself inside someone else's brain and try to think what they're thinking and like mind read them. But they start you off with some fill-ins, and maybe there is comfort for you guys right now in the fill-ins to not have to do it yourself, to build up that way. But it might be easier to just like try to think it through yourself with practice. I don't know what to tell you. But there'll be a longer homework to do for sure, because there's 16 of these to try to do, which you might think is bad. I'm changing the directions at least to make it better. So on 112, we are going to ignore their advice. They want, in their mind, they say copy all of this stuff and complete the proof. I'm saying no, don't copy anything, just complete the proof. The only one I'll ask you to copy anything is number 16. Number 16 is a full-blown do-it-yourself proof. There's only one of those. So on 16, I'm going to say, yes, copy the given, copy the proof, copy the picture, make the columns, do the stuff. But for these other problems, I'm not going to ask you to copy anything. If I did, I feel like that would be the worst writing assignment ever. You'd be basically copying like 4 pages out of the book, and that just feels unnecessary to me. You just need to find a way to number, like, number 8, reason 1 is this. Number 8, reason 3 is this. Number 8, statement 2 is this. Just find a way to number that in a way that you know what's what and I know what's what. But that's what we want to do with this. I'd start that for tomorrow. We'll probably start to talk about that tomorrow. We'll finish talking about that Monday. It'll take us a little while. That would be more of a Monday collection. But if you wait to do that till like Sunday night, Monday morning, you're going to regret that. This is not a fun homework to do necessarily in one big sitting. This is more of a spread it out homework. Question about the 116? The packet, if you look at the back of the packet, I didn't give you as much information at the end as I have on some other packets. So what this says about the homework is there's 20 points of proof stuff. By 20 points of proof stuff, I mean there's 20 points like this page 112 homework assignment. So the page 112 homework assignment we'll spend 2 days poking through. There's 20 points on the test that are like that one. Then there's a miscellaneous 35 points of other pages. But I didn't give you my favorite problems list. So there's definitely been conversations where I've said, like, don't lose sleep over this one. Like you asked me about the one with the 2 equations, 2 variables. That's not going to make the test. I already made that pretty clear. The ones that make the test tend to be more the ones I've done problems from the notes. Like there was a day that I came in the notes and I drew you this picture like 3 times. And then the homework had maybe 3 again like that. That's a safe bet that makes the test. Like it's more the ones that you had note problems, example problems that are more the test problems, but there's less specific stuff on there. But what we'll talk about homework for a few days. If you have homeworks you don't get as you're working, we'll just keep talking about it. Question about homework, future life, what that is? Okay. Let's do a quick example proof and then we'll probably call it a day. Bella's coming soon. So I didn't copy the prove on this one on purpose just to see if somebody could come up with it. So this is straight out of the book. You don't have to write this down. You can if you want to, but it's a reworked version. The book did this proof. I'm going to do it. It's just going to be a little different when I do it because everybody's a little different. But it says, given angle DAB is congruent to angle DBA. I like to mark stuff on my pictures. That's going to be a skill that you're going to want to grow. So angle DAB is right here. That's congruent to angle DBA. That's right there. So I'm going to mark those with the same kind of markings as each other so I can just see at a quick glance those guys are twins. It also says angle CAD, which is upstairs, is a match for angle CBD, which is the upstairs over there. I'm going to mark those so that I can see they're the same as each other, but they're different than the ones I had before. Okay, so these are a match with each other, those are a match with each other, but they're each the same. Can anybody figure out where this would have to go? If these angles matched and those angles match, what truth would have to be out there?
They matches.
Who matches?
Did CAB and
CAB would have to match
CBA.
CBA. That's where we're headed. If the downstairs pieces match and the upstairs pieces match, if we put them together, the whole big corner would have to match the other whole big corner. That would have to be true. It's just a matter of us trying to explain why. Some of you will like proofs, some of you this won't grow on you. I'll say this, if as a young person you enjoy puzzles, there's a chance you may like this. If as a young person you enjoy mazes, there's a chance you may like this. You never went into a puzzle wondering, wonder what this will be. You knew how it was going to go, okay? The problem was getting there. You never went to complete a maze and thought, gee, I wonder where I'm supposed to finish, because it said, finish maze here, start maze there. The path was what you were working on. If you've ever found those kind of jobs entertaining, you may grow to like this. If you always hated those kind of jobs, you probably won't like this because it's the same kind of thing. We're trying to get from here to here like a puzzle or a maze or something. What should I do here?
Copy the given.
Copy the given. In the interest of time, I'm not going to do that. Over here, I'm going to write given. Then we have to ask ourselves, if angles are congruent, what do we know about that? You have a definition of congruent angles.
Measures are the same.
The measures are the same. And I don't think I have time to do all the details of that, but I could do two of those. Then what are we basically doing here?
The angle addition postulate.
We're doing the angle addition postulate. If you just focus your attention there, that sure looks like an angle addition postulate thing. The angle addition postulate is going to be measure of the big equals measure of the little plus measure of the other little. You can do that twice. I told you the angle addition postulate tends to have friends with it another day in that conversation. Who might be the angle addition postulate's friend?
Addition property of equality.
Addition property of equality. Why are they friends? They're addition. If I give you little things and want you to put it together, that's going to be the addition property of equality. What if I did the same thing, but I told you the big ones matched and I wanted you to somehow shrink them?
Subtraction.
Then you would do subtraction instead of addition. Addition property of equality would look something like this. And if I had this full statement written, but I don't think I have time for it, something here would reappear there. And something here would reappear there. And you get all this reappearing stuff. What tends to be the reason that comes in when you get this repeating stuff? It will be, but when we get repeats. If there's a bunch of days I've gone through rows and repeated people's names in comparison, it is transitive. Anytime we get some repeated stuff, it's going to be a transitive activity. I ran out of space But if we're trying to eventually say angles are congruent, what's our only thing that could be used to do that most likely? Definition of congruent angles again. Definition of congruent angles gets us out of congruence toward measures. It can get us back out of these measures, back into congruence. It's in the book, but that's like another just sample partial proof. That's about as much detail though as I could do there. You had a question 103, so let me answer your 103 question before we run away. The 103 into number 8 asked why you had to use the reflexive property before you could use the supplement theorem. So, what's the supplement theorem say?
Supplements of congruent angles. Right?
Supplements of congruent angles are congruent. The only way you can use that theorem is if you have some congruent angles. If you don't have any congruent angles, you can't use the supplement theorem yet. And what the reflexive property can get you is some congruent angles to like get things going. So that's what that number 8 was about.